Okay, today we're going to look at how energy flows and how that causes phase changes. So, some vocabulary here. The word endo, or the prefix endo, means to enter. The prefix exo means to exit. And then thermic means energy. So these are some words that you will see here in the coming slides. When we put some of these words together, endothermic means that we have energy entering. Exothermic means we have energy exiting. The form of energy that we're most often talking about with endo and exothermic is chemical energy. This is a form of potential energy that is stored in the bonds of chemical compounds. When we break those bonds, we need to use up energy, or breaking bonds takes energy, and when we make bonds, they release energy. So we have two types of chemical reactions. We have exothermic and endothermic. Endothermic is when we have energy entering the reaction. That means that more bonds are broken than are made. So it takes energy to break bonds, and it gives off energy to make bonds. So if we're overall taking energy, that means the amount of bonds broken are greater than the amount of bonds made. What you will feel is cold. Now this is kind of counterintuitive. We have energy entering the system, which means that the reaction is taking energy, but what we feel is cold because it takes that energy from the surrounding areas and causes that cold feeling. Next, we have exothermic. This is when energy exits the reaction. And what happens there is that there are more bonds made, which give off energy, than are broken, which take energy. So we have an overall extra amount of energy because of those bonds being made. What we feel here is warmth, okay? So that's the energy given off. Good example of this endothermic is like those instant cold packs, instant ice packs, where you break the inner bag and shake it up and it gets cold. Exothermic then is like the hand warmer packets, where when you open them up to air, they get warm. Reactions take place in two steps. First, the bonds must be broken in the starting reactants. When bonds are broken, energy is needed, so this is endothermic. Okay. Then those separated atoms, so those broken apart atoms, join to form new bonds to make the products. Energy is released to form the bonds, so this process is exothermic. When we look at changes in the state of matter having to do with endo and exothermic, we can think of those changes as endo or exo as well. Thinking about the energy of the particles is how we do that. So you're going to think, are the particles moving faster before or after? So, for example, in melting, we have a solid, which, remember, way back to our air unit, has slow-moving particles. They're just barely vibrating. And that solid is melting into a liquid, which has faster-moving particles. The particles take energy to increase in speed, which means this is an endothermic process. Okay, again, this is really counterintuitive because if we think of like an ice cube, solid ice is much colder than liquid water. When we're reading a heating curve right here, this is kind of how we can see how much energy. Now, temperature, as we've learned, is a measure of kinetic energy, which is the energy of motion. So it's how quickly those particles are vibrating. So when it's a solid down here, it's at a very low temperature. Notice that melting during our phase change, the temperature doesn't change. That's not because energy is not being added to the system. What's happening there is all the energy that is added is going in to change from a solid to a liquid, which means the temperature can't rise. The temperature continues to be added throughout the liquid stage until we get to the point where we have boiling or evaporation occurring. Okay, so at this point, the temperature levels off again because all of the energy is going to changing from a liquid to a gas. And then finally we have gas. Now, heating curves here could go gas down to liquid, down to solid, or they can go upwards. Okay, we're looking at, they should always be temperature, compared to the amount of heat. Now, this is some new vocabulary you'll need to know. Okay, these phase changes. When we go from solid to liquid, you guys should know that one. That's melting. Liquid to solid is freezing. Liquid to gas is evaporation, and gas to liquid is condensation. The two you might not be as familiar with are these solid to gas, which is sublimation, and gas to solid, which is deposition. Okay, what we're thinking about here is, are the particles becoming faster or slower? So when we go from solid to the gas, the solid particles are just barely vibrating. The gas particles are moving faster. So you're going to need to think, what is happening here? The particles are becoming faster. It takes energy to do that. So that is an endothermic process. Sublimation is endothermic. Deposition, then, the opposite of that, we're going from fast-moving particles to slower-moving particles. So their energy is given off, which means that's an exothermic process. Make sure you've added in all of the spots allotted for in the notes. There might have been some things that weren't necessarily on the slide, but that were said throughout the PowerPoint. Make sure you've answered all the questions and ask your teacher if you need any help.